Hi everyone. Today we're going to be completing our notes on graphing sine and cosine with horizontal shifts. So let's start off with this warm-up. The graph of g is given. This is this graph right here. Describe how the following graphs would be obtained from g of x. Then sketch the graphs of the following functions. So letter A, this is going to be a horizontal shift to the left 2 pi units. Okay, so we're going to take all these values and we're going to shift them left 2 pi units. Well, I know that every increment is pi halves, so that tells me that every 2 increments is pi, or every 4 increments is 2 pi units. So that tells me that each of these points I'm going to move to the left 4 increments. So 1, 2, 3, 4. We have our first point here. We hit a maximum, midline, minimum, and then midline. So this new function looks like this after a horizontal shift 2 pi units left. For letter B, we have negative g of x, so this is going to be a reflection over the x-axis. And so that means that all of our y values are going to be flipped from positive to negative and negative to positive. Or zeros are going to be zeros, still zeros, because 0 doesn't have a sign. It's not positive nor negative. All right, so we have this graph here. Letter C, we have g of x minus 2. This is a vertical shift down 2 units. So we're going to take all of our y values and shift them down 2 units. So we have this graph here. Okay. For letter D, we have 2 times g of x. This is going to be a vertical stretch by a factor of 2. And so what that's going to do is it's going to multiply all of our y values by 2. You might notice that the amplitude of this sine wave is multiplied by a factor of 2. Okay, so we have a greater amplitude, an amplitude of 2. And then finally, letter E, we have y equals g of 2x. This is going to be a horizontal compression by a factor of 1/2. Okay, it's going to take all of our x values and it's going to cut them in half. So we have this kind of horizontally squished wave. Notice all the y values are still the same though. We still have from -1 to 1. All right. So go ahead and flip the page. Let's try example 1. For the function g of x is equal to -3 cosine of the quantity x plus pi halves. So letter A, let's go ahead and describe the transformations from the parent function y equals the cosine of x. Our first transformation is going to be on the inside of our parentheses. This is going to be transformations to the input. So we have a horizontal shift, left pi halves units. Our second transformation is going to be that negative out in front. That's going to be a reflection over the x-axis. And finally, our third transformation is going to be a 3 out in front. That is a vertical stretch by a factor of 3. Okay. So let's go ahead and create a table of values, letter B, for the parent function, y equals the cosine of x, and then also for g of x. Okay. So y equals the cosine of x. We'll start with just our quadrantals. We have 0, pi halves, pi, 3 pi halves, and 2 pi. Our values for cosine are 1, 0, -1, 0, and 1. For our transform function, we're going to take all of our inputs and we're going to shift them to the left pi halves units. So we have negative pi halves. Our pi halves becomes 0. Our pi becomes pi halves. Our 3 pi halves becomes pi. And then our 2 pi becomes 3 pi halves. All of our x values are going to be shifted to the left pi halves units. All of our y values are going to be multiplied by -3. So our 1 becomes -3. 0 stays 0. Our 1 becomes positive, our -1 becomes +3. Our 0 stays 0, and then our 1 becomes negative 3. All right, so let's go ahead and plot these points. Negative pi halves, negative 3. That's going to be right here. We have 0, 0. We have pi halves 3. We have pi 0. And 3 pi halves, negative 3. Go ahead and fill in the rest of the grid. So continue the pattern until you fill in the whole grid. Okay. Draw that wave shape. Try not to have any corners in your graph. At the ends, you might notice that we hit maximums, so please do not exceed those maximums. Curl your tails back down. And then don't forget to draw the arrowheads at the end of your graph to indicate that the graph goes on infinitely in both directions. Okay, so your graph should hopefully look something like this. Okay. Let's try another example. F of x is equal to the sine of 2 times the quantity x minus pi fourths, all minus 1. There's a few transformations here. The first is the horizontal compression by a factor of 1/2. Next is that horizontal shift, right pi fourths units. Okay. And then our last transformation is that vertical shift, down 1 unit. Okay. So we'll start with our parent function, x and sine of x. And then we'll go ahead and evaluate for x f of x. So x sine of x, we have our quadrantals, 0, pi halves, pi, 3 pi halves, and 2 pi. And our sine values are going to be 0, 1, 0, negative 1, and 0. For our transform function, f of x, we're going to take all of our inputs, and we are going to divide them all by 2, and then we're going to shift them to the right pi fourths units. Okay? So our first one is going to be 0. So divided by 2 is 0. Shifted to the right pi fourths units is pi fourths. Pi halves divided by 2 is pi fourths, and then shifted to the right pi fourths units is pi halves again. Pi divided by 2 is pi halves. Shifted to the right pi fourths units is 3 pi fourths. 3 pi halves divided by 2 is 3 pi sixths. And then shifted to the right, 3 pi fourths, and then shifted to the right pi fourths units is pi. And then finally 2 pi divided by 2 is pi. Shifted to the right pi fourths units is 5 pi fourths. Okay, so these are our new values. All of our y values are going to be shifted down 1 unit. So we have negative 1, 0, negative 1, negative 2, and negative 1. Okay, so let's go ahead and plot these points. We have pi fourths, negative 1. We have pi halves, 0. We have 3 pi fourths, negative 1. We have pi, negative 2. And we have 5 pi fourths, negative 1. There we go. So go ahead and fill in the rest of the grid with the pattern. Sketch your wave. And then draw your arrowheads. I like to plot all of my points before I draw it because it helps me draw a smooth curve. If you're comfortable with it, you can just go ahead and sketch in the curve without drawing in all of the points. It's totally up to you. I personally like how my graphs come out. When I do that, it helps me draw it. So do whatever is easiest for you. Okay. So draw those arrowheads on both ends and you've got the wave here. All right, let's continue. Example 3. So write the equation of a cosine function that has an amplitude of 1, is reflected over the x-axis, and has a period of 8 pi and a midline at y equals 2. Let's start with that period. So we know that period is equal to 2 pi over b, right? So I'm going to use my period, 8 pi, and I'm going to use that to find my b value. So I know that if I were to multiply both sides by b and divide both sides by 8 pi, I'm going to get b is equal to 2 pi over 8 pi. Well, I know that 2 pi over 8 pi reduces to 1/4. So I know that my b value is going to be 1/4. I have y is equal to, the first number is going to be our amplitude. Well, our amplitude is 1, so there's not going to be any scalar multiple in front of my trig function. There's not going to be a vertical stretch. We have that it's reflected over the x-axis, so that's going to be my negative cosine. So remember, that graph is going to start at a minimum, come up, hit a maximum, and then return to a minimum. We have cosine of the b value, 1/4 x, and then we have a midline of 2. Remember that vertical shift is going to affect the midline. We have y equals 2, that's positive 2. So our equation is this right here. Y equals the negative cosine of 1/4 x plus 2. Okay. All right, let's try some practice. Go ahead and flip the page. We have a few examples on this page. So the first one is g of x is equal to 3 cosine of 2x minus pi. The first thing I want to do here is factor out that argument here. So we have 3 plus cosine of, factor out that 2. When you factor out that 2, you get x minus pi halves. That helps us determine our transformations. So we have, I notice that my b value is 2, and we have a horizontal shift to the right pi halves units. Okay. We also have a vertical shift up 3 units. So to graph this, I'm going to start with my y value, my midline. I know that my midline is y equals 3. That's determined by my vertical shift. Next, I notice that my period, so I'm going to go ahead and write that, period is equal to 2 pi over b, and I know that my b value is 2. So 2 pi over 2 tells me that my period is going to be pi. Okay? So we're looking from 0 to pi. But now we want to shift it to the right pi halves units. So now we're going to go from pi halves units, instead of 0 to pi, we're going to go from pi halves units to 3 pi halves units. Okay? So that's going to be one full cycle. And then from there, we're just graphing the regular cosine. So remember, the regular cosine starts above the midline. It comes down, hits the midline, then hits a minimum, hits the midline, and then hits that maximum. So here's the one cycle here that we're graphing. Double check before you fill in the rest of the grid that this is shifted up 3. It's got a period of pi, and then it's shifted to the right pi halves units, not in that order. All right. So then once you have that and you've confirmed your graph, you can go ahead and plot the rest of the points. So I'm going to go ahead and fill the grid and draw in those points for that repeated behavior. Okay. Once we graph our graph, then we can find the y-intercept. And this one's got a lot of waves to it, so it might take you a moment to draw it. Okay. As a reminder, curl those tails down. We don't want to exceed those maximums. Okay, so the y-intercept here, we can clearly see that it is 0, 2. All right, so number 2, we have negative 2 sine of 3x plus 1. So we'll start with our period. We've got our b value is 3. So the period is equal to 2 pi over b, or 2 pi thirds. So our period is 2 pi thirds. We have a vertical shift up 1, so that's going to define our midline to be y equals 1. And last, we have a negative sign, so I'm just going to go ahead and sketch the shape of negative sign. Sine always starts and ends at the midline, but instead of going up and then down, we're going to go down, then up, and then back down. Okay, And then we have an amplitude of 2. So that's that number out in front. Okay. So if we're not shifting to the right, so we're going to start at x equals 0. Okay, so we have our midline right here. We have our period of 2 pi thirds. So we know that one full cycle is going to fit in between here. All right. In between that, we've got to hit that minimum and we've got to hit that maximum. Okay. So here's the shape of the graph right here. Here's one cycle. Again, double check your work that we're graphing negative sine with an amplitude of 2. So actually, good thing I double checked. I've got to correct that. So we have, there we go. Our minimum is -1 and our maximum is +3. All right, so now we've got that amplitude of 2. We've got our period of 2 pi thirds, and then we've got that vertical shift up 1 unit. Okay, so now we can sketch in the rest of our grid. And this one's going to be kind of tall and narrow. Okay. All right, and then draw it in the negative half as well. Okay. So you can kind of see the difference in these graphs. I definitely like to plot those points. You can see how it helps me. The y-intercept here is 0, 1. Okay. All right, we got 2 more for today. I'm going to go ahead and let you try these on your own. So at this point, go ahead and pause the video and try these on your own. When you're ready, unpause and then check your work. All right, so here are the answers. So for number 3, here is the graph. The y-intercept is going to be 0 square root of 2. Okay, if you were to plug in 0 here, you'd have 0 plus pi fourths, which is pi fourths. We'd have 2 times the sine of pi fourths. Well, the sine of pi fourths is root 2 over 2, so times 2 is going to be just root 2. There is no b value, so this is just our normal period, 0 to 2 pi. We're looking at the sine graph, so it's going to start at the midline. It's going to go up, hit a maximum, back to the midline, minimum, back to the midline. So this is a sine graph shifted to the left pi fourths units. Midline is going to be y equals 0. Number 4, we have 3 cosine of 1/3 x. So this is going to be a horizontal stretch by a factor of 3 and an amplitude, a vertical stretch by a factor of 3. So our period is going to be 6 pi. So if every increment is pi, then I should see it start at a maximum here and then end at a maximum at 6 pi. Okay? We have a minimum at 3 pi. Fill in the grid and sketch the rest of your points. Okay, let's do the last one together, number 5 at the bottom of the page. Number 5 says, write the equation of the curve that has a period of pi thirds, a maximum of 6, and a minimum of 2. So, and this is a sine curve. So I know that I'm going to have y is equal to the sine of something, right? Well, it's going to have a period of pi thirds, and I know that period is equal to 2 pi over b. So that's going to help me find my b value. If I take my b value and divide both sides by pi thirds and multiply both sides by b, I'm going to get b is equal to 2 pi divided by pi thirds. Well, this is going to be equal to just 6. So that tells me that my b value is going to be 6. So we have sine of 6x here. So we've dealt with our period now. Our maximum of 6 and minimum of 2. So we know that amplitude, we discussed, is 1/2 the difference of the max and min. So if we take our max of 6, we subtract our minimum and divide by 2, that's going to give us our amplitude. 6 minus 2 is 4 over 2 is 2. So that tells me that my amplitude, my a value out in front, is going to be 2. Okay? Our midline is going to be equal to the average of the max and min. So if we take max plus min, and we divide them by 2, that's going to give us our midline. So 6 plus 2 over 2 is 8 over 2, or 4. So our midline, or our vertical shift, is going to be up 4 units, and this satisfies all the criteria. You can double check your max and min by taking your 2 and adding it and subtracting it from our midline, and that's going to tell us our max and min. Okay? All right, so we've gotten a lot of practice on this. We're going to get more in class, so we'll see you tomorrow. Goodbye, everyone.